Okay, we're just waiting for the rest of the people to join us. All right. So how'd it go?
All right.
Good.
Yeah. All right.
Yes.
Okay. So let's go ahead and start with group number 1, which was Elijah, Eric, and Noah. So what did you guys come up with? How do you explain square roots, and what is the opposite operation?
We said a square root of a number is a value that, when multiplied by itself, given the number explained.
Okay.
Or I mean, given. Sorry.
Right. So what would be the opposite operation then?
Cube root.
Oh, I don't know. Like,
Okay. Let's go to room 2 where it was April, Alana, and Eliza. What did you guys come up with? How do you explain square roots, and what is the opposite operation?
For the explaining square roots, it's the number times itself.
Okay, but all right. What about the opposite operation?
It's an inverse operation to finding the square root of the number.
Okay. What about room 3, which was Gordo and Lejean? So how do you explain square roots?
Basically just a number times itself.
Okay. And the opposite operation?
Will basically be like multiplication and division switched. And the same thing will be for addition and subtraction.
Okay. So in a way, we're sort of on the right track, but there are a couple things that are, like a little bit, I guess, confused. Okay. So let's just talk about a little bit about what the square roots are. Okay. So what we want to look at is just first, we're going to write down 2 keywords, right? We have our perfect squares. And then we have our imperfect squares, right? Those are the 2 keywords that we are going to discuss. Perfect squares and imperfect squares. So make sure we just have those written down. Okay. So let me know when we can move on.
all right, I'm good.
Good.
Done.
This was good. Good. Okay.
I'm good.
Yeah.
So what I heard a lot was that the square root is basically the number times itself. Now, we sort of got that, I think, a little bit mixed up, okay? Remember, we talked about exponents the very first day on Tuesday, right? We talked about the exponents, and we said when we have 3 squared, for example, that's when what we're saying is 3 times 3, which is equal to 9. So we call it 3 squared. But then how do we go back to a 3? If I had a 9, what can I do to it to go back to a 3?
Don't you subtract?
Well,
You
yeah.
divide it by 3.
Right.
No, I'm kidding.
Yeah.
Or would you divide?
Okay, so I'm hearing a couple other things. So you guys aren't wrong. We could subtract, sure. We could divide. But let's see. Let me put it another way. let's think about 9 as being equal to 3 squared. Can we agree with that? Because 3 squared is 9, right?
Yes.
So how do we cancel out that exponent is a better question. Do we have an idea?
Put 9 squared.
9 squared, well, if we do 9 squared, that would just give us 81, right?
Then, oh my, then why didn't you put a negative?
Well, what do you mean, like -2?
Yeah.
Well, -2, according to our properties of exponents, would actually be turned into a fraction, right? And again, this is stuff from last year that we went over, okay? There's a couple different questions, so the way that we do that is actually going to be by taking the square root. Okay? See that? So the square root of 9 is 3. And when we take 3 squared and we take the square root of that, that cancels out. So we're left with 3. So in other words, when we say 3 squared, that's 3 times 3, right? But when we want to go back to 3, we have to take the square root of 9. Okay, that is the opposite operation, and that's what we're trying to talk about, right? The square root is just the opposite operation of 3 squared, okay? And if you're a little bit confused, just hold on for a second. We're going to go back to it, okay? So let's just first talk about why we call it squaring. So 5 squared, we agree that is the same thing as saying 5 times 5, right? So let's pretend 5 and 5 were the sides of a shape, right?
Mm-hmm.
If we multiply those together, the area would be 25. But the area of what kind of shape? What would that make if we have two sides that are the same?
A square.
A square, yeah. Ever set the square? Exactly. If two of the sides are the same, that means all the sides are the same, right? So that's why we call it squaring, okay? Because when we square a number, we're literally creating a square with an area of 25, right? Same thing if, I don't know, let's say we had 6 squared, right? That's the same thing as saying we have a square with sides 6, 6, and the area, what would the area be?
36.
36, exactly. Okay, so that's why we call it squaring, okay? Now, if we take the opposite way, let's say we're talking about 49, right?
7.
And we want to find the side of the square. How would we find that?
Find the square root.
Find the square root, exactly. So if we take the square root, what would be the square root
7.
of 49?
7.
7. So that means that the sides are going to be 7. Okay? Does that make a little more sense?
Yeah.
Uh-huh.
Yeah.
Good.
I'm fucking sore.
You good, G?
I'm sorry, bro.
Oh. You worked out yesterday?
Yeah.
Oh.
Okay. So I want you guys to write these down, okay? And sort of like make sure that you always know these, okay? The square root of 1, square root of 4, square root of 9, square root of 16, 25, 36, 49, 49, 64,
81,
81, and 100.
100.
Okay. So these are what we call perfect squares, right? If we take the square root of 1, that's 1. The square root of 4 is 2.
2,
Square root of 9 is
3,
3. Square root of 16 is
4,
4, and
5,
so on, right? 5, 6, 7,
7, 8.
9, and 10. You could actually keep going and say 121. It's the next one, 144, right? That's 11, and that's 12, right? So we need to remember these are what we call our perfect squares, right? Because when we take the square root of these numbers, we are going to get a nice round number without any decimals, okay? So we always need to remember, make sure we write those down, keep them handy because they're gonna be important later on.
Mm-hmm.
Okay, let me know when we got them.
I'm good.
I'm good.
Good.
Me and Eliza are good.
Okay, all right. Okay. So this next part is going to be pretty important because we're gonna do this a lot in geometry. Okay. So next, we're going to look at what we call imperfect squares, right? So if I take the square root of 18, right? That's an imperfect square because that would give us a decimal, right? So really, the answer to this would actually be about 4.24, right? There's a lot more decimals, but I'm just rounding, right? So this doesn't give us a whole number. It doesn't give us a nice round number. We have decimals, okay? So we really want to avoid that, okay? And geometry, what we're gonna do, and we did this a little bit last year in Algebra 1, we are going to simplify the square root, okay? So the way that we're gonna do this is that we're gonna find two factors. One of them has to be a perfect square, and the other one, well, just one of them has to be a perfect square, okay? So what two factors of 18 can we have where one of them is a perfect square?
One.
Right, one, but we usually avoid one because it doesn't really simplify it, right? So let's just think about it. 18, the factors of 18 are 1 and 8, 2 and 9,
3 and
3 and
6.
6, and so on, right? Which one of these has a perfect square?
9 and 2 and 9.
Yeah, there we go, 2 and 9, right? So we can actually split this into 2 and 9. Okay, so if we take the square root of 9, what do we end up with?
3.
3. So the answer, 3 square root of 2. Okay? And so this is a better way of writing the numbers because instead of having decimals, we have nice round numbers. Yeah? Does that make sense?
Yes. Sir.
Yeah.
Okay. Let's try it now with the square root of 75.
Oh God.
So a really nice trick is that it ends in 5. So what's a factor of 75 that easily ends in 5?
Right? 14 and 1.
Oh,
No.
no.
15, isn't it?
What about
5 times 15.
5 times 15? Well, neither of those are perfect. perfect squares.
Oh,
How about 25 and 3?
Oh yeah.
So 25 times 3 gives us a 75, right? And if we
Mhm.
take the square root of 25, what does that give
It's
us? 5.
5.
So 5 square root of 3.
Oh, okay.
Okay, a little bit better.
Mhm.
So in other words, we want to find the factors, and one of them has to be a perfect square. Okay. So let's try it again. What about the square root of 98?
Hold on.
Let's see. 98 is an even number, right? So what happens if we divide 98 by 2?
You get 34.
34, are you sure?
I mean, wait.
you would get 49.
49, exactly.
Yeah.
So if you divide 98 by 2, then we get 49. So what's the square root of 49?
7.
7. So 7 square root of 2 would be our simplified version.
Okay.
Okay?
All right.
That make a little bit more sense?
Yeah.
Okay. All right, so last thing. Let's say we have a fraction. Let's say we have 36 divided by 25, and we take the square root of that. What do you think would happen there?
Hold on. It would be one. No, what the? I don't know. 1 and then 11 over 25.
Where are we getting 11 from?
I don't know
1.2.
because
Yeah,
36.
be like 1.2.
Okay, sure. So it'd be 1.2, but again, we don't really want to write things in decimals, right?
Go 6 over 5.
Good, actually. We can rewrite this as 36 and 25. Now, are 36 and 25 perfect squares?
Mm-hmm.
Yes, right? So what's the square root of 36?
6.
And the square root of 25?
5.
5, right? So we just know that whenever we have a fraction, we can rewrite it as the square root of something over the square root of the other number, right?
Uh-huh.
Just a couple of things, that we need to remember, okay? So again, we need to make sure that we're really good at simplifying the square roots as much as we can, okay? And reason being is because we're gonna work with those a lot in geometry, okay? It's always easier to work with simplified square roots instead of working with decimals, okay? So that's why we need to make sure that we're good with this. Okay, let's see if we can try another one. Second. What about the square root of 50?
Square root of 50.
25 to 25.
25 and 2?
Yeah.
2, yeah.
Oh, yeah.
So see if we take the square root of 25, and we get 5 square root of 2. So what we want to do is, just list out the factors if you're not sure, right? 1 and 50, 2 and 25, 5 and 10, right?
Mm-hmm.
And let's just pick out the one that has a perfect square. Okay, let's see, what about the square root of 72?
Square root of 72.
Yeah, first clue that you should have is that it's an even number. So what happens if we
36
divide it
and
by
2.
2? Huh?
36 and 2.
There we go, 36 and 2. If we divide it by 2, then we have 36 and 2. So the square root of 36 would be what?
6.
6 and
There we go. Square root of 2. So again, you know, the reason we simplify them like this is so we can avoid decimals, okay? And for me, it's like, as when you go into higher level math, you always want to avoid decimals as much as you can, okay? Especially like the calculus problems that I'm working on. We always want to avoid decimals until the very end, and then sometimes they'll just tell you, okay, write your answer in decimal form or whatever it is. But we always want to make sure to avoid using them, because then they just make everything much harder than it has to be. Okay? All right, so it's about 30 minutes. Let's see what else. Okay. Now, before we go, I just want to make sure, is there anyone that still hasn't signed up for Remind?
Hold on, let me check.
For you, Rod, I don't think I have.
Let me see. I think so far the only ones I have are Gordo, Lejean, Elijah, Alana, Noah, and April. So
Yeah, I'm not in it.
yeah, please do that.
Hey, what's the code?
Let me send it to you. So in the chat, remember you have to text 81010, and then the code is going to be at C78GHE. Okay. So again, just because if I send out announcements or anything that I need, that just send you guys some messages in case, you know, if you're missing anything, I can let you guys know right away. All right.
I'll finish your slides today, Rod.
Yeah, sounds good.
Yeah.
So remember that we're not gonna have a meeting tomorrow, okay? It's only from Monday through Thursday. I'm gonna post this just in case you guys missed anything, or if you need to go back and review. And there's gonna be another homework assignment on Delta Math, okay? So you're gonna practice taking the square root of a number and squaring numbers, as well as simplifying radicals, which is the square roots, okay? So you're gonna practice all those things on Delta Math. And remember, if you guys have any problems, you can always let me know. And what else? Go ahead. Tomorrow I'm gonna have another morning post. Make sure to comment on that so I can take it for attendance since we're not meeting tomorrow, okay? And everything is, all your homework for the week is due tomorrow as well. So make sure to,
Rod,
Wait,
yeah?
what time is it due?
Get on your class. For the thing.
Yeah, let me,
Hey, Rod, what time is our homework due?
well, at midnight, so like at
Yeah.
11:59, okay? So
Okay.
as long as it's done tomorrow by the end of the day, Friday, okay?
Yes, sir.
You guys should have plenty of time. I suggest you guys just do it now so you don't have to worry about it tomorrow, right?
Yes, sir.
Mm-hmm.
Okay, so if you guys don't have any more questions, that should be all for today, okay? Make sure again for those of you that haven't joined Remind, please do so right now, okay?
Yes, sir.
Otherwise, Have a good day.